Rosalia, you're from ASU. I have a cousin who's a graduate student at ASU as well in STEM education. Oh, welcome, Jennifer, Tom, Heather.
And I like to start about 5 past the hour, and that's where we are. Thanks everybody for attending and signing up for this. I am excited to be introducing Carrie Diaz Eaton to give our webinar for this month. Carrie, take it away.
Thanks so much, Alexis, for the invitation to come to this community to talk a little bit about some of the work that I've been doing. Alexis and I ran into each other as part of an effort for Sea Change to reach out to the mathematics community and talk a little bit about what that might look like for us. And so I always find it's fun to do some boundary spanning across the STEM disciplines, and I look forward to also hearing how this resonates or might work, or some of these ideas might be realized in your contexts. I'm going to talk about models and assumptions for inclusive STEM education. I'm kind of a modeler by training, and so I just can't help but think of everything as a model, and maybe you'll see some similarities as we go on today. But first, because this is an education talk, I'm going to do an activity. I bet you didn't think that I was going to give you work to do during a webinar, so I apologize to anybody who's driving. But yeah, we're going to start with a bit of an activity. It's going to be a race, an information fact-finding race. I'm going to give you 2 minutes, and everybody is in different areas, but why don't we do, we're going to try to find the most efficient way to get from DC to New York City. I'm going to give you 2 minutes. You can use whatever resources you want, and go. I'll keep a timer for you. Sometimes when I'm doing this in class, I have a really annoying big screen countdown timer to get you extra nervous about the time. Might be very obnoxious. Okay. 1 minute left. In just 1 minute. Okay, 30 seconds left. Just 30 seconds. Just 30 seconds. Fifteen seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So okay, that's it. Time's up. Let's talk about it. I know that there isn't really a chat functionality, so I'll do my best to sort of see what folks are writing in the Q&A. Instead of telling me how you did it, I want you to answer a slightly different prompt, which is, what assumptions did you make? So if you could just spend a second and type something in the Q&A, that would be awesome, and I'll read them out. So we got the Acela. Oh, somebody was assuming flying. So Acela, for folks, is the Amtrak train. Someone tried to balance both fastest and environmentally efficient. So maybe that wouldn't be a plane. Somebody assumed that money was no object and you had convenient transportation to and from train stations in order to land on Acela. Tom assumes he was a human being trying to get himself from within city limits of DC to city limits of NYC. So kind of anywhere at any point of in and out. Richard said cost, time, low carbon footprint. That's how he also landed on Acela. What else? Assumed that online maps would be pretty accurate to finding efficient time or miles, so using some additional tools there. Okay, so this is great. I think I try to say, or try to be as obnoxious as possible as I can, sort of online, trying to count down timer, though somebody said that maybe actually the unlabeled clock was more anxious because you had no sense of time. Maybe, that's a different sort of anxiety. And part of the reason I did that really obnoxiously on the fly, very little time, on purpose, was that folks tend to make the most assumptions that are comfortable with them when time is crunched, when you have to make these very quick, off the cuff assessments. And so I think it's a good kind of way to get everybody's sort of first impulse assumptions. So, an example is flying, for example. So that is certainly very quick. Once you're in the air, it's very quick. I guess you have to think about what about transportation to particular hubs. But also flying takes certain forms of identification, and there are certain laws that are in place coming up to require a more limited set of identifications, the real ID laws. So that may or may not be something that everyone has, is a real ID, real being like the acronymed real, not making a judgment call about what's real. So, that might be true, for example, of some undocumented students. It might be the case just for various other reasons, maybe in an area where just public transit is a thing, never had to go get a driver's license before. I mean, there could be a variety of reasons why somebody might not have the identification for particular modes of travel. Somebody mentioned transportation to and from public large stations in DC and New York City for taking the train. I think this is a really good point. I know that both my parents are physically disabled, and as a result, taking public transportation is actually not always actually available for them for certain train stations where you might need to transfer and things like that. It's a very big deal to have to do that. So I think there are the assumptions that I think some of us were making, whether or not we thought about the environment or, being environmentally sensitive, that, might reflect your own personal commitments, whether or not you really cared about the cost, maybe you'd be willing to go 15 hours more if you didn't want to spend money for a plane ticket, or you didn't want to take that form for environmental reasons. there are all sorts of reasons why we make assumptions about what efficient means in our lives. And so I think this is a great sort of entry in to the theme of today's talk. For those who are interested, I do have a whole blog around this. I can try to remember to share it later, but I think if you Google, you might be able to find it as well. I just want to contextualize a little bit about me. So, I mentioned I was a modeler, so I'd like to sort of contextualize how I came to this place. So I am trained as a math biologist. My degrees are in mathematics, but my area of interest was in biology research. And I worked at first in computational neurobiology and then switched to evolutionary ecology, studying the evolution of communities, and now mostly do STEM education research with a dabbling of disease ecology on the side, based on student interest. But that STEM education, really, because I was a math biologist, was really rooted in interdisciplinary education, really understanding how to teach mathematical quantitative topics to folks in environmental sciences and biology. And then from there, it became a little bit more expansive. I started teaching computational skills and started getting really into the area of data science education. And all along the way, have been working to think about how we are shaping our disciplines, not just in ways that promote inclusivity from a disciplinary perspective, but also from other perspectives, including social identity perspectives. And so that's kind of what I want to bring to you today, is a little bit of a perspective on how some of these things fit together. That's kind of the work that I'm involved in at the Rios Institute. My regular time job is as an associate professor of digital and computational studies at a small liberal arts college in Maine called Bates College. Maine obviously is not the background here. The background here is completely aspirational. It's me wishing for summer. And this year I'm on sabbatical with visiting research appointments at Brown University and University of Chicago. The work I do at Rios is part of a center that I founded, co-founded and run. And we've been doing a lot of not just research on STEM education, but also professional development opportunities and learning communities around just having some time and space and support to talk through relevant and upcoming issues in thinking about inclusive and open STEM education. So I invite you to check it out. The evolution that I went through, I think, is in my personal trajectory, I think is mirrored by a really nice quote from an environmental justice leader, Chico Mendes. He said he was known for his activism in saving and working on rainforest conservation in South America. And he talks about this because he was in the sort of rubber tree farming business. At first, I was fighting to save rubber trees. Then I thought I was fighting to save the Amazon rainforest. Now I realize I am fighting for humanity. And I think this very much encapsulates kind of my own trajectory, which I got into studying questions in biology because I very much wanted to sort of save the world. And then I really wanted to work on sort of the environmental conservation issues. And then as I started doing this work and research, I started realizing that those environmental issues were not disentangled from my own social identities and the social identities of the communities involved in these issues. And, how can you advocate for the most environmentally conservative mode of transportation when you're just trying to figure out how to get to the train station, I think is one way of putting that. One example of how this appeared was in a paper that some colleagues and I put together probably a decade ago, that was published about in 2018. And it was this really, really nice research group that was met at the National Institute for Mathematical Biology and Synthesis at the University of Tennessee. And we were getting together in this, I guess what could be called post-vision and change kind of era, soon after, a few years after biology had socialized a vision and change report produced by AAAS about what should we be teaching in the biology discipline to meet needs of the 21st century. And there was a huge emphasis on modeling and quantitative skills in that report. And so a group of us came together to think about, well, what are the best practices for teaching modeling to biology majors, both from the biology side and the mathematics side. And that research group involved mathematics educators, education researchers, biology education researchers, STEM education researchers, physics education researchers, as well as math biology researchers who were sort of interested in the teaching questions as well. And we had this working group that lasted across a little over 2 years. We met 3 times, and the first meeting was great, but really by the end of that first meeting, we started reading papers together, et cetera. And there was still something kind of really nagging at us this whole time. And we realized that language was a huge barrier. You wouldn't think that it is. We all certainly have common interests. We're all here for the same reason. But we got the sense that when we used the word model or modeling, because we wanted to solve, how do we teach this? But even the word, how do we teach what? We all had very different definitions and versions of what models and modeling were. And it took us some real sitting down and working through that particular conversation that really was a sort of transition into sort of making progress on that task. So we had to have this cultural negotiation between the group about what we were actually talking about and laying out some definitions. And it was that the result of those cultural negotiations, this framework for models and modeling that was published, which is this sort of idea that models are all the things that all of the people in the room were thinking about. That includes the mathematical models. It also includes the lab models, the mouse models. It includes the schematic models, the visual drawings. It includes the data itself. The data itself are a representation of some idea, and it includes the experiential, the sort of setting up the lab as well. And I think that was really important for a variety of reasons. It sort of gave everybody an understanding of where we were all coming from and how we all fit into that bigger picture of what we were working for. And in particular, I think the mathematicians were leaving out the experiential in a particular sort of way. I think the experiential that is usually in a math lab is sort of doing it on doing simulations on a computer or worksheets. Not exactly the same as being out in the field or setting up your own lab experiment. Could be, but it's not always characterized in that way. And that was sort of missing an essential sort of identity component from the scientist side, where that's where students first enter. For example, I sat in on a marine biology course, and the very first meeting was going out to the field. And students were so much more engaged in that very first class. than they were in my mathematics class, where the first day was a syllabus discussion. And I have learned from that experience and changed what first day engagement looks like. As we started to dive into this cultural negotiation, one of the things that became really clear was it wasn't just about the language, but the way that the language was used to include and exclude. So as an example, one of my colleagues, she had been working in data science via genomics and bioinformatics. And her department had said that her research didn't count, or she had to completely justify over and over again her research because it wasn't hypothesis driven. And now we're talking, 15 years ago, so a lot has maybe changed since then. But this is a fight that folks had to make. I had talked about how when I was on the job market, how a lot of folks, especially in biology, would come up to me and say, "Oh, yeah, I hear you're a math biologist. I have this data," and I would be like, "Wait, I don't work with real data. I work with theory and models, and that has nothing to do with data." And in my head, I didn't understand what the real ask was. First of all, that I was missing that they also do modeling just with real collected data, and I should be open to that. And also I was not understanding that they were extending me an olive branch. They wanted to find some common ground, and I was rejecting that opportunity. And so as we were talking through these sort of various cases, the other thing that became clear was that sometimes why we were saying what counts and what doesn't seemed to be completely based on the cultural norms of the discipline and nothing that we can change. They were often very much intertwined with other kinds of social identities. So pre-tenure woman faculty in a predominantly male department, for example. Conversations with faculty of color, again, pre-tenure, where their research, maybe it wasn't excluded because it was, I already mentioned a case where it was excluded because it wasn't hypothesis driven, but sometimes research not being included, or their students' research not being included because they didn't collect their own data. They were doing something theoretical or used data from a large database. These I think raise some questions that original paper didn't get into, other than we had called it disciplinary microaggressions, but we're ignoring the fact that those disciplinary microaggressions were very often related to the social identities of the folks involved. This was usually very much entwined. And so I think we need to be thinking about to what extent are our arguments or our cultures about the science we do and the disciplinary culture, or to what extent is it actually about the people that are doing them? I'll also sort of step back a bit and say that I think about this as creating a model of STEM and what it is, who does it, who is it for, who are we serving, and therefore, what is our model of STEM education, and how is that really implemented in our teaching and research? So with that in mind, I'm going to sort of kind of zoom out and think about some of these stories that I just kind of told, but from that broader lens. And I hope, even though I'm coming to this work from mathematics and biology, I hope we can sort of all see together that this idea of questioning and verifying and making and modifying assumptions, exploring assumptions, testing assumptions, that's all part of the common science or mathematics that we do together. So I think what I'm sharing is applicable sort of across many spaces. The first place I want to talk about it is in our teaching. So I at one point I had sort of subtitled this talk hidden as everything everywhere all at once because I feel like I think that's what I'm talking about here is there are a lot of places to make change. I think it needs to happen everywhere. Everything everywhere all at once needs to be changed. I think you should find some places where maybe this resonates with you and think about how this might work in your own context. So I'm going to sort of share a variety of ideas and hopefully leave some space open for reflection. So one set of scales would be like at the classroom level, if you're an instructor in the classroom, if you are involved in the governance of your curriculum, or whether that's at a department level or a professional society level, setting standards for your discipline, or thinking about the broader picture of all teachers together. I want to sort of think about that set of scales and then prompt you with questions about different pieces of that. So for example, people. So how are you thinking about people in the classroom and their relationship to STEM? Who is represented in your classrooms? Not just who's sitting there, who is intellectually represented in your classrooms? Have you done an audit around who is represented in, whose work is represented in your classroom? Does that reflect who you want to have as scientists out of your classroom or out of your program, et cetera? Context. So what is the context of your work? And I know that for many many parts of STEM disciplines, this might be very easy because they're very applied oriented STEM. Some it may be a little bit more, it might feel a little bit more detached. I'll give an example of sort of a progression I've made in my own teaching. At one point, when I was teaching calculus, and I was talking about introducing first order differential equations. So we were talking about exponential growth. It's the easiest first order differential equation because it's the rate of change is proportional to the amount. And the sort of classic exponential growth, well, there were folks might think about it is CO2 data. And at first, when I started and had this project sort of identifying or computing rates of change across, between data points, I just called it an environmental indicator. And I went that way for a while. At least it was environmental. I called it an environmental indicator. It was just a arbitrary data set or line of some that I had given them. And then as I went through, I realized, no. I mean, I can attach this to data because I need to be working with data. This is how my students come into my classroom. They've already taken statistics. They've already collected data in the lab. They need to be grounded in that data experience for me to add sort of mathematical equations in that particular context. And so then I said, okay, well, let's think about data. So I went to that carbon dioxide data. And so I built out the context more of climate change and long-term data collection at Mauna Loa Observatory. And then I was able, from the data, to construct a exponential function, and then they analyzed that particular exponential function. As I continued progressing through my learning and scholarship and started thinking more about this inclusion more than from a disciplinary perspective, I started to think about, I started to hear about Mauna Kea in the news. And I realized Mauna Kea, Mauna Loa, maybe I should be paying attention to this. And I think actually it opened some really interesting conversations about where the data was collected, what implications that might have, in a way that thinking about some arbitrary exponential function that was an environmental indicator never opened for me in the classroom. But I think it's just as important to be talking about indigenous sovereignty and the meaning of land, and the benefits and possible drawbacks of certain sites for observatories. And that is all part of the context that I was often not making room for, but making room for it, certainly, I think it makes it much richer. So I already gave an example of sort of the assumptions we make in terms of the classroom activity we just did. That activity actually I have in a very intro first year seminar course. So I think there's places where you can start reflecting about who's represented, how is it represented, what assumptions are we making. Once we have a data or a model, like how are we interpreting those results? How are we communicating those results to different folks? Sort of classic examples of the same data set being interpreted in multiple ways. One example being, education research, finding disparities being interpreted as, gap gazing between groups in achievement as measured by tests versus debts accrued, educational debts accrued by society to students, and a recognition that we've not been serving. And this is the gap we've created through inequity and racism. So I think there are ways that even though we'd like to say that the science we do is neutral, there are all sorts of places along the way that we make choices to decontextualize or interpret or communicate our values throughout that process. The other thing I'll leave you is sort of what are we doing? What is our goal for our STEM curriculum? What if our goal for students out of our STEM experience was to give them joy and purpose and a deep understanding and engagement in the process as a result? What if our purpose was to democratize knowledge? And that's how we contextualized, the need for open STEM education, or using open educational resources, and valuing the importance of community engaged work in the classroom. What if our goal was to empower students to value their strengths and perspectives, and to help them really feel like they have agency over quantitative information in a society that's so dependent on it these days? So how does that sort of change how and why we're doing what we're doing in the classroom? I won't read this whole excerpt, just to say that one of the ways that I explain some of this is after I do the exercise on sort of an efficient way to get to New York City, is through an excerpt in Data Feminism by Lauren Klein. And again, this is the entry that I make into this work because of the emphasis on data. But it's really thinking about our different perspectives, not as or different lived experiences as just different, and not less than, but something that is important to our work. If we accept that our models, our data, our science is not as neutral as we'd like it to be, then that sort of gives science an identity crisis. And what is the best way to think about that? Is that a flaw of science? And what's suggested in data feminism is that the pathway here is to be upfront and open about your positionality and how that is informing your approach and your interpretation, et cetera. And certainly this is often done in many fields already in terms of disciplinary positionality, coming to particular interpretations from, built on certain theories from particular sectors. And this is how I'm approaching this work. I think we're less used to doing this based on our understanding of how the world works outside of the classroom. But I think it's just as important because, again, what is efficient for some might not be accessible to others. And I think it's important to remind ourselves of that and really benefit from that diversity in viewpoints. One of the sort of urgent calls, I think, for some of this re-envisioning, I think, was over the pandemic. Everybody sort of references the pandemic in terms of the sort of our teaching needs, but I think it's also just as important to think about this from a research perspective as well. We made a lot of assumptions about folks being sort of rational decision makers in the pandemic. We made and rational can be defined in a number of ways, but I think we deprioritized, human social needs. So again, some of the mathematicians were making quite a few assumptions, and myself included, about what people needed or wanted, making a few assumptions about how the world worked and who could afford and who it was realistic to have stay in their house and isolate and who wasn't. There were a lot of models for decision making for folks trying to hold big events, but there was very little help or modeling for folks just trying to make decisions whether or not they should go to a relative's house for Thanksgiving. And that was a very difficult kind of gap in the knowledge base. We were basing recommendations for, concerning O2 levels based on the idea that everyone would have the same sensitivity of response on O2 detectors, regardless of their melatonin level, which was later shown as something that wasn't true. So I think that there's a lot of places where this is not just limited to thinking about pandemic changes, about accessibility, about classroom needs and so needs for connection in the classroom that came out of the pandemic, but also the way we think about our research and the role of science and that connection to society that could be sort of re-examined. So I kind of want to bring some of the same questions to light, but just kind of think on a parallel track here. What does it look like to think about people in your research or in your lab setting? For example, thinking about, who's in your lab, who's doing the science, who is being cited in the science, who are you collaborating with? I have a colleague who has done sort of a co-author audit and looked at gender, race, ethnicity, et cetera, of their co-authors to see if they could hold themselves accountable for limiting, their collaboration potentially to sort of the spaces that are dominated by at elite colleges where he is in mathematics. Context, assumptions. We just talked about a variety of assumptions. I think there are folks who are doing great work thinking about the role of society in these decisions, but I do think that some of our disciplines are not as connected or not reading the work by scholars in social sciences and humanities or collaborating with those disciplines or with the community. I think that's a skill that many in our community could continue to work on. Through the sort of, whole process of science, you could sort of think about this. What if the goal of doing or being in a lab together was to foster joy, purpose, empowerment, belonging? What if the goal of your science was to democratize knowledge? How would, then of course, this sort of open science movement is a given from that assumption or axiom or whatever you'd like to call it in this case. What if our culture of research in STEM valued collaboration and public engagement and connections with people? How would that change things? I'll give a couple of really quick examples for what this looks like in some of the research I'm doing right now. I'm running these semester-long programs at math institutes and on data science and social justice, and we made an intentional decision to have introductions that were not poster sessions to each other's research. We wanted to do something fun to get together, and we did not want our interactions throughout the rest of our time together to be predicated on who's at what university and who has more or less, computational or data science skills or whatever the valued currency is. I've seen a lot of meetings that have started that way with this sort of positioning discussion among colleagues that are meeting for the first time. And I think that's not the kind of research environment that I would like to create. I think it looks, we planned getting food together at a variety of places that were, represented, that were folks' favorite foods or representative of folks' cultural identities. For example, myself and another Peruvian ordered Peruvian food for the whole group one day because we were so excited to share Peruvian food with everyone else, and we were in a city that had multiple Peruvian restaurants. What is it like to ask folks starting in a research enterprise together, whether that be students in your lab, new colleagues in a research group, ask, what is it that you want out of this? Where are you in your career, and what is valued in the places you're going to, and how can we support that? So that's, thinking about, if it's really hard to get published in data science for social justice research, which it is, thinking about, okay, maybe we need to have some special issues to make sure there's, a venue or identify some journals or editors that are going to be open to that work. Developing a priori research guidelines, authorship guidelines rather. And then, even in the research practices we do, encouraging, again, open science, really trying to be very careful about potential ethical issues when we do share data online, again, auditing our own citation practices. I think there's so much that we can sort of think of, whether you're a researcher or a classroom teacher primarily, or whether you're somebody who is involved in policy in each of these spaces or in informal, whatever. I think that there is something from these practices that we can take back and think about, how might things be different if we centered humans as those making science instead of science as science because it is. And so I think the big question is, what kind of physics community, what kind of biology community, what kind of math community do we want to cultivate? Because that's what we're doing in these leadership positions in our classrooms, in our research labs. We're cultivating a community, and how are we going to be attentive to cultivating a community that is changing towards equity and inclusion for justice. So thank you very much for letting me share some of these thoughts, and I hope I left some time for questions.
You did indeed. We have about 10 minutes and we have some questions already, and feel free to enter them in the Q&A and I will ask them aloud. So the first question is, have you talked to economists about the assumptions in their model?
Yeah, so it's really interesting. Maybe about I can't even remember exactly the time, but I'm going to say maybe about 8 years ago or so, less than a decade ago. I was at a conference. I think it was a math biology conference, and there was a sort of famous math biologist researcher giving a plenary talk, and I asked, a lot of these models are based on folks, making assumptions that we're rational human beings, but we're not. And so, how do we change our epidemiological models to reflect this? And they said, we need to pay attention to the work of economists. And so I think it's a good point. I think I tried to include this also a little bit as I saw the question pop up, but I think we, if we're not, we should seek out knowledge and collaborations that improve our work to center humanity from those who already think about those questions all the time, whether that be in a variety of social sciences, sociology, economics. And I'm certainly cognizant that within economics, there's a lot of heterogeneity. There's a lot of variation in how that's treated. And some models are about rational human beings, and some specifically relax that assumption in particular ways. I had a research student recently that had looked at a lot of sort of impacts on human behavior. I had a lab involved for a long time looking at gameplay of humans versus zombies and modeling that, and modeling it as predator prey or as disease or et cetera. And actually we found that there was a sort of a superhuman sort of squad that did not want to get turned into zombies and cooperated together. And so we're especially resistant in our disease models, shall we say. And that actually was an important human behavior characteristic that without accounting for, our models were doing terribly. And then once we accounted for that, we called them warrior humans. We were able to have models that fit much, much better. Another student extended this research, but thinking about COVID modeling and thinking about human behavior and decision making in COVID modeling. And it turns out that, depending on your sort of risk assessment, you can have very differing, depending on how your community reacts or thinks about their own risk, you can have sort of very different outcomes for how disease is managed on college campuses, as long as you have a surveillance system. And if folks conservatively estimate their level of risk, you can maintain COVID levels, even despite, kind of oscillations due to parties and breaks beneath sort of critical thresholds. But if the community is not thinking about their own risks and much riskier as a whole, then you'll have to rely on measures like lockdown to keep it below emergency. And so I think ignoring human behavior is a problem. And that's all connected to public health literature and economics literature as well. So I think making these connections is extraordinarily important, and modeling that in our STEM classrooms.
Great, thanks. And then somebody asked about how do people get involved in this work that you're sort of talking about, thinking about what kinds of positions might be available in physics.
Yeah, so I mean, of course, like Bates College usually has hires, but oftentimes visiting positions if you are finishing your PhD. We actually just incorporated we voted, this is like hot press breaking news. A couple of weeks ago, we voted to incorporate 2 new requirements into the general education graduation requirements of our majors across all majors, including STEM, which focus on race and power and privilege. One of them has to be specifically offered by the department. So we are certain, to focus on how these kinds of issues affect your discipline. And another can be taken by students in any other department. So we're making a lot of really exciting curricular transformation changes, and so certainly finding institutions with those kinds of commitments helps, and getting connected to that network. The math community is running a number of if you're in the sort of math areas or tangential to, or might be interested in working with mathematicians, because it's not all mathematicians, there are a number of sort of research opportunities coming up. I mentioned doing a long program and Math Institute, ICERM at Brown University in Providence. And while the long-term research positions are spoken for, we are running 2 workshops, one on data science and social justice and policy. And that is in June, and then another one in education, and that is in July. So you can ICERM, so you can search for it, and applications are still open, I believe, for both workshops, which include travel and funding support. And then I know in 2023 in the fall, there will be a long research program at Berkeley at the Math Institute there, SL Math. And in fall of 2024, there will be a math and racial justice workshop at SL Math again. So that I'm sure some of these conversations are happening in other places as well. In biology, I'm hosting the Gordon Research Conference on undergraduate biology education in June, this June. There's like only a dozen spaces left. So if you're in the biology areas and want to be involved in that conversation, please apply as soon as possible, because we're almost full. So hopefully that gives a few on-ramps. You can also follow me on Twitter, Math Prof Carrie. I tweet things off when I can.
And so one final question, because we're at top of the hour, is how do you think physics and math could work together to do some of this rehumanizing work in our departments, you know, broader than our departments and so on?
Yeah, I think that's really a great question. The way obviously I came to here was by working with physics on some trying to think about how math might adopt the sea change frameworks, and that's, I think, work still ongoing, but I think more invitations to talk across would be great, both directions. I think and I think actually we have a physics education, at least one physics education research speaker in the Gordon Research Conference in the biology area. I think it'd be great if folks started to work together across, and I think sometimes the spaces to do that are limited. So, hey, if you want to make a party, let's invite me to the party. I think it'd be great. I found some really nice spaces. The AAAS conference this year was kind of great for those cross community conversations. I find SOCNUS really a great place as well. But I'm sure that I think it would behoove us to have more conversations across disciplines. I believe there's also a cross-DBER community that has been trying to form. It used to exist in an incarnation called Truce, and now I think it's called XDBER. Not quite the same community, but pretty close. I think they just finished a virtual conference, or they have one upcoming, but hopefully, as we return to some in-person as well, there'll be even more opportunities for these kinds of collaborative conversations.
Great. Well, thank you so much for your time. I don't see any more questions, so I will stop the recording.